Okay, so far we've been looking at polynomials in an abstract kind of way. However, now we have to kind of think about our graphs from a realistic way of how they look, because they can be plotted and they are a graph. So when we're looking at polynomial, this is an example of one, we have our bunch of different things that we need to know about. So the main one, the first one that we kind of already know about, there are 3 of these for cubics, generally, and these are intersections with the x-axis. And from National 5, we should know that roots are what we call where it intersects with the x-axis, okay? The x-axis. Okay, and these are found when y equals 0. It's how you find roots. Set y equal to 0. Okay, and this is why we're factorizing, because this gives us our roots. And the other option, the other thing on here is that you've got your y-intercept, so where it intercepts the y-axis. Okay, and the y-intercept we find when x equals 0, so we substitute that in, x equals 0, and we can find our y-intercept. And the last thing that we have are stationary points. And these, at the minute, won't mean very much, but they will become a lot more important as we go through the higher course. So that's another stationary point. It's where the graph stops going down and starts going up again, or where it stops going up and starts going down again. Okay, and these roots that we have from our graphs can be found in a bunch of different ways, but just that's the introduction of how kind of cubic functions look. So let's have a think about what can we maybe do with this and how is it going to help us. Right, so if we have the graph y equals x cubed minus 3x plus 2, okay, and we want to find the y-intercept and roots. Okay, so this is where this is headed. It's similar to National 5. Okay, so to be able to find your roots, you should remember from National 5 you need to factorize to find your roots. So that's what we need to do here as well. The easiest bit to do first, though, is to find the y-intercept, as the y-intercept is where x equals 0. So therefore y equals 0 cubed minus 3 times 0 plus 2. So that's equal to 2. So the y-intercept is 0, 2. That's a point on our graph we could use to plot this if we wanted to. Okay, and then we need to find our factors. So we need to try factors of 2. Okay, so if we let x equal 1, we'll have a try. So that means we get y is equal to 1 cubed minus 3 times 1 plus 2. So 1 minus 3 plus 2, which is equal to 0. Therefore, as remainder 0, x minus 1 is a factor. Okay, and you need to justify this, so you need to write that sentence there, like the as remainder 0, x minus 1 is a factor. It's really important. So we can now use synthetic division. So we've got our x cubed, our x squared, our x, and our constant. So we're going to have 1, 0, minus 3, and 2 from our coefficients. and we're doing 1, so 1 times 1 is 1, 0 add 1 is 1, 1 times 1 is 1, minus 3 add 1 is minus 2, and then minus 2 times 1 is minus 2, so we get 0. And then we can use this to factorize this. So we know we have to set it equal to 0, so because we're finding the roots, and when we find the roots we have to set it equal to 0, so we have x minus 1, and then in the brackets we're going to have x squared plus x minus 2 from our quotient down here, which is equal to 0. So we have x minus 1, factorize this, what multiplies to give us minus 2, but adds to give us 1 has got to be plus 2 and minus 1. Okay, and that's equal to 0, so that gives us x minus 1 equals 0, x plus 2 equals 0, and x minus 1 equals 0. Okay, so that gives us x equals 1, x equals minus 2, or x equals 1. So that means we have a repeated root. Okay, so we're going to have the points for this, the y, where it intercepts with the x-axis, are going to be 1, 0, and minus 2, 0. And remember that what a repeated root is means that the graph will come down and touch the axis and then go straight back up again. So at the point 1, 0, what you're going to have is a repeated root like that. Okay, and the graph is going to go through the point 0, 2, and it's going to go through the point minus 2, 0 as well. Okay, you could use the graph, you could graph this as a way of showing that, but at the minute it's just asking you to find the intercepts. Okay, so that's us for finding the intercepts of and roots for these polynomials. If you have any questions, leave a comment and I will get back to you. If you want any more examples, let me know. That's fine. I can do more examples, it's not a problem. And thank you for watching. Please like or subscribe.